The Earth has a radius of 6,381 kilometers, but while it seems like a simple sphere, if we look deeper into its inner structures, many phenomena we can observe on the surface of the planet can be explained. From the magnetic field to earthquakes and even tectonic activity, the inner structure of Earth plays a huge part in the formation of life as it is today.
Beginning with the basics of the Earth's structure, the Earth can be divided into layers in two main ways: through chemical composition and mechanical properties. Chemical composition is the most common way of sorting layers, which uses mineralogy differences to determine the boundaries of layers. On the other hand, mechanical classification of layers involves categorizing by the properties of each layer, like phase and viscosity. To further understand the two systems, we will now create a drawing of the Earth, which shows both the chemical and mechanical boundaries. This will display how the different structures compare. The crust is the outermost layer of the rock that we are all familiar with. It is anywhere from 5 to 70 kilometers thick and is broken into two main sections: continental crust and oceanic crust. Shockingly, the oceanic crust lies below the oceans and is generally between 5 to 10 kilometers thick. Since it is composed of mafic igneous rocks like basalt, it is overall more dense than continental crust. Continental crust is made of less dense felsic rock, such as granite, with a thickness ranging widely since the elevation of the Earth's continental crust varies at different locations. The mantle is the next layer of the chemical structure. It is a somewhat viscous plastic layer which allows plates to move on it. The mantle is the thickest layer of the Earth, with a depth of approximately 2,900 kilometers. Because of this, its properties vary greatly and can be divided into upper and lower mantle. The upper mantle is solid and made mainly of peridotite and perovskite, while the lower mantle is less solid due to the high temperatures. The outer core is fully liquefied, with a depth of 2,260 kilometers. It is composed mostly of iron and nickel, with the possibility of sulfur and oxygen also being present. It has a density of between 9.9 and 12.2 grams per centimeter cubed. Scientists learned of its liquid state due to the fact that shear waves can't pass through this section of the Earth. However, much of the other properties of this layer aren't fully known or understood. The inner core has a radius of 1,220 kilometers and is a sphere made of an extremely similar iron and nickel alloy that the outer core is made of. However, it is a solid instead of a liquid. The density is between 12.8 and 13.1 grams per centimeter cubed. Moving on to the mechanical classification of layers, the first layer is the lithosphere. The lithosphere includes the crust and the uppermost part of the mantle. This layer is considered a solid and is very brittle. The lithosphere consists of the plates, which move in plate tectonics, and is generally 150 to 200 kilometers. Some parts of this layer can be as thin as 10 kilometers, however, due to the unusual hotspots which result in extremely thin lithosphere. The asthenosphere is the next mechanical layer. It has some liquid properties resulting from higher pressures and temperatures, but is not fully a liquid, more of like a putty substance. This property of the asthenosphere is what allows the plate tectonics of the lithosphere to move around, and it is the magma source for volcanoes and mid-ocean ridges. It is about 500 kilometers in width, but can be as deep as 700 kilometers in some areas. Now comes the mesosphere. Relative to the chemical structure of the Earth, this includes most of the mantle, going from the edge of the asthenosphere to the bottom of the mantle. While in the asthenosphere the temperature is high enough to partially melt the rocks, in the mesosphere the high pressure essentially cancels the effect of the high temperatures, making the mesosphere a solid. The mesosphere is the largest portion of the mechanical layers at around 2,200 kilometers of depth. The innermost mechanical layers, otherwise known as the inner and outer core, follow the same classifications as the chemical layers. For the outer core, the high temperatures allow for liquid metal to exist in this range. However, for the inner core, the pressure is too great and this portion is solid, even though the temperature is estimated to be over 6,000 degrees Celsius.
We've explained the thickness of each layer, but many people have no sense of scale when we say 1 kilometer, 200 kilometers, or even 700 kilometers. So to give a sense of reference, let's look at how the Colorado School of Mines campus compares to each layer of the Earth. The scale we've chosen goes from the center plaza between the Student Center and the Rec Center to the edge of the street in front of Volk Sports Complex. The whole radius and scale is 1,093 feet, or about 1/5 of a mile. The crust's average thickness is about 30 kilometers thick. After plugging that into the equation we developed, compared to the rest of campus, we only need to move approximately 5.1 feet, or 2 to 3 steps before we enter the mantle. The mantle is the largest portion of Earth's systems, covering over 2,800 kilometers on average. On our scale, this would be over a third of the distance across campus and approximately 494 feet, putting us in front of the library from Volk Gymnasium. The outer core is an average of 2,260 kilometers wide and is a very high temperature liquid. The distance it would cover across campus is approximately 386 feet, and would place us just past the traditional halls and about halfway to Berthoud Hall. Lastly, the inner core, which has a radius of about 1,120 kilometers, would take up the remaining 208 feet and bring us all the way to the center of the plaza, finishing the long journey through the Earth and hopefully contextualizing the relative thickness of the layers, so it's easier for everyone to understand exactly how they all compare.